Right, so today we're going to learn about something called complex numbers. So we've been doing radicals for, what, a couple weeks now? Okay, so if I asked you what the square root of -4 was, what would you tell me? Is it -2? We talked about this, right? Square root of -4. Can I do it? No. How about the cube root of -8? Yes, what's that? -2. Okay, why can't I do the square root of -4? The index is 2. It's an even index, right? There's no two negative numbers. -2 times -2 isn't going to give me a -4. Okay, so there's no possible way for this to equal -2. Does that make sense to you guys? Okay, so what actually winds up happening is we get into something called imaginary numbers, or complex numbers, where we're actually able to take the square root, or the 4th root, or the 6th root, or the 8th root of these negative values. Okay, so that's what we're going to talk about today. Let's go on to the next picture. Okay, so how can we take the square root of a negative value? Square root of -1. I want you to go ahead and insert a calculator page. And I want you to do the square root of -1 and see what your calculator tells you. God bless you. Non-real calculation. Okay, so let's take a peek. We'll have you. All right, so we get something called non-real calculation. Okay, that's because the solution is not real. It's imaginary. Okay, and imaginary numbers do actually exist. They're used when we talk about electricity all the time. Okay, so we have to set up our calculator in order for it to work with these imaginary numbers. So here's what I want you to do. Is everybody ready? Hit your dock key, please. You're going to go down to Settings and Status, which is choice 7. Please select Document Settings, choice 2. And you see where it says real or complex? I want you to go down there and change that. There's an option called rectangular. Okay, please select rectangular. Pardon me. And make that default. And OK. Okay, so now that our calculator can actually work with these values, I want you to go ahead and put that, thank you, whoever this is, square root of -1 in again. And what does it give me? I. What do you think I stands for? Imaginary. Good. Okay, so when we take the square root of a negative, we get an imaginary value. Okay, go back to your notes. All right, so again, what's the square root of -1? I. It's actually plus and minus I. Okay, plus and minus I. Where do I find that plus minus? In the book. Tab 3, so hit 3. And it's right next to the caret. It's underneath the greater than sign. There you go. And the I, you're going to look in your pi key, which is down next to the H. And there it is. Okay, it isn't a normal I. It's a fancy I. It's imaginary I. Okay, do you normally take your notes in the calculator or on paper? Okay. All right, so if we're talking about the square root of -4, what do you think it's going to be? Plus and minus 2i. Good. So what's the square root of 4? 2. But we have that negative, so what do I need? We have the negative, so what do I need? What does that negative give us? The I. Okay? So the way this actually gets broken down, square root of -1 and square root of 4. Right? What's the square root of -1? I. What's the square root of 4? 2. So that's where we get that I from. Okay? You can always pull out that square root of -1. Same thing. You guys okay with that? Okay. All right, so what do you think the square root of -16 is? Good, plus and minus 4i. Great. All right. Let's move a little further down. Go back. Yep, go back again. Further down on the page, please. Okay. All right, so now we have square root of negative 18. Is 18 a perfect square? No, but can it be simplified? Absolutely. Okay, so I want you guys to see if you can break that apart, simplify it out, and get your... Okay, so tell me how you broke down negative 18. 9 and 2. One of those has to be negative. Which one do you think it goes with? That 9. Why the 9? It's the perfect square. Good. You want it to be with the perfect square. Okay? So what's the square root of negative 9? Plus or minus 3i. Okay, now you got to be careful. Yeah, you got to have the plus or minus 3 radical 2 and then I at the end. The I always goes at the end. Okay? Is the I underneath the radical? No. Will it ever be under the radical? Will you ever put it there? Ever, ever, ever? Okay. So that I goes at the end. 3 plus radical 2i. So go ahead and try radical negative 72. Ready? Let's break down 72. Negative 36 and 2. Okay, so what'd you get? How do we do? It's not bad, right? So as long as you know how to reduce the radicals, you know that if you have a negative in there, you can take that out. And it gives you that I, value of I. Now, does it work for cube roots? No. Why not? Yeah, it simplifies without it. How about fourth roots? Yeah, take out that I again. Okay, good. All right, let's move page, another page forward. Okay, so the nice thing about imaginary numbers is they are cyclic in nature. What does cyclic mean? They have a cycle. What do you mean? Up and down, and it's like an oscillation. Give me something that's cyclic in nature. The weather, the seasons, the tide, right? The moon. Those are all cyclic, okay? So, very, 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 very important piece to this, and you have to have this memorized. If square root of negative 1 equals I, what's I squared equal? Negative 1. Why? Yeah, if I square this, I also have to square this. What's the square root of negative 1 squared? Negative 1. So what's I squared equal to? Do you have to have that memorized? Yeah, absolutely. Pound that into your brains, please. Okay? I squared is equal to a negative 1. All right, so I was just saying that this is cyclic in nature, correct? So this has a cycle, meaning there's a pattern to it. And everything goes by force. Okay? What's I to the first power? I. Anything to the first power is its base, right? I squared? Negative 1, because you have to have that memorized, right? I cubed? How do you think you could find out? Yeah. Put in the calculator, see what you get. Your calculator can now work with imaginary numbers, right? So what's I cubed? Negative I. And what do you think I to the fourth is? Positive 1. I, negative I, negative I, 1. I, negative I, negative I, 1. I, negative I, negative I, 1. And it goes over and over and over again. So what would I to the fifth be? I. How about I to the sixth? How about I to the seventh? How about I to the eighth? How about I to the ninth? You get my point? Over and over and over again. So if I asked you what I to the 99th power was, are you going to do this out 99 times? No, you'd have to be crazy to do that. You have a calculator that does magic. What do you think you should do? Okay. So should you ever get a complex number problem wrong if they ask you like I to the 101st power? No. I want you to please find me I to the 101st power. What'd you get? I. We're struggling with this concept. We're good? Okay. So, cyclic, I, negative 1, negative I, 1. You have to know that I squared is equal to negative 1. Okay? Okie dokie. Turn to the next page. All right. So, along with imaginary numbers is complex numbers. Okay? What a complex number is, it's the sum or the difference of an imaginary number and a real number. Give me an example of an imaginary number. Square root of negative 1 equals what? I. I is an imaginary number. What else is an imaginary number? 2i. How about 3i? How about negative 5i? How about square root of 2i? Anything with I is an imaginary number. Very good. Okay. Give what? I stands for genius. Okay. So give me an example of a real number. 2, 4, 6, 12, 8. We're only using positive numbers now. 7, negative 5, 32, square root of 2, pi, all real numbers. If a number isn't real, what is it? Imaginary. Okay, if it's not real, it's imaginary. If it's not imaginary, it's real. Okay, so an example of a complex number, 2 plus 4i. There you go, that's a complex number. Another example of a complex number, square root of 2 minus 3i. That's an imaginary number. Another imaginary number, complex number. How about negative 1 plus I? That's a complex number. Anybody notice that I'm writing it the same exact way every time? I is always at the end. So this form is a plus bi. Okay? That is how we write complex numbers. A being my real part and bi being my imaginary. Okay? If you don't write it in a plus bi form, is it wrong? Yes, please write it in a plus bi form. Okay? They take off points on the Regents exam if you don't. If they specify, please state your answer in a plus bi form, and you write it as I minus 1, it's wrong. Got it? Good. Okay, so before we can perform operations on our handhelds, we have to change it, but we already did. How did we change our handheld so it could work with imaginary and complex numbers? Yes, we changed our settings to rectangular. Okay? All right, so let's see how this all works. Now, adding complex numbers is how we're going to start. We're going to start off nice and easy. This is the example we're going to do. I'm aware that it's not in your calculator. Please type it in. No, on the left-hand side, please. All right, so I have 2 plus 3i plus negative 4 minus 7i. Any ideas why I have them in parentheses? Yeah, they're two separate numbers, okay? It's a whole number. It's a whole complex number. So I put it in parentheses to show that it's a whole, that's one number there, okay? All right, so if I wanted to add these together, how do you think I would do it by hand? I would. How? Am I multiplying? Okay, I don't know why you guys always, whenever you see two sets of parentheses, you guys are like, FOIL. No, okay? You just add what? The same families. Give me math terms, please. Like terms. We got to combine our like terms, right? So what are my real terms? 2 and negative 4, which gives me negative 2. And what are my imaginary terms? 3 and negative 7i, 3i and negative 7i, which gives me negative 4i. So there's the sum of the two complex numbers. Difficult? Do you think our calculator does it for us? Absolutely. Do you have to know how to do it by hand? Yep, absolutely. Okay? So I want you to go ahead and take that, put it onto the calculator side of the page, and see if it gives you the same thing. How do you highlight? You can highlight by holding down Shift and pressing back, and it will highlight it for you. Shift and back will highlight. Then you can hit Control-C to copy and Control-V to paste, just like on the computer. V, Control-C, Control-V. Did we get the same answer? Yes, indeedy. What do you think? Well, I mean a little. Adding's pretty simple, I would think, yeah? Yeah. Okay, so let's go to subtraction. Subtraction's a little bit different. Little bit different. If I was subtracting two binomials, what would I have to remember to do? What? Keep, change. Yes. Okay, so if we're subtracting polynomials, we know we have to distribute through that negative, correct? Okay, so we get 2 minus 5i Distribute through the negative. Plus 2 minus 8i. So when we're subtracting complex numbers, you have to remember to change the signs in that second piece. Okay? Now what can you do? Now what can you do? Just combine like terms, yeah. 4 minus 13i. Okay. Will your calculator do subtraction for you? Yeah, what do you want to make sure that you have? Put the parentheses in there. So go ahead and put it in your calculator, see if it works for you. You absolutely should have gotten the same thing. So if you didn't, you typed it in wrong. Always the original. Four minus 13i. We're good? Okay. Next page. Multiplying complex numbers. Oh, well, you're missing a negative in there. That's why. Multiplying. So, now you can say it.
Foil.
Oh, because we're multiplying, right? So yes, we can FOIL those out. So you guys are more than capable of multiplying that out. Go ahead and do so, and we'll go over it in a second. Okay. Ready?
Yep.
2 times 2 is?
4.
Genius. 2 times negative 3i? Negative 6i, and then negative 15i squared. Hey, what's I squared equal? Yes. Say it again. What's I squared equal?
-1.
Okay. So 4 plus 4i minus 15 times -1. Can't leave the I squared in there. It equals something. It equals -1. That's the point of this. Okay. So 4 plus 4i plus 15. Are we okay with that? 19 plus 4i. Why do I keep writing 14? Yes. Okay, so please put that in your calculator. Make sure you get the same thing. Do you? Okay, we good? Next page. Let's talk about division. Now, division's a little bit different, okay? You cannot have an imaginary value in the denominator of a fraction. Just like you cannot have a radical in the denominator of a fraction. How did we remove a radical? Multiply by, we multiply by something. How did we get rid of the radicals? It's going to be on your quiz tomorrow. You guys obviously haven't studied. What? Multiply by the, what? Ludmila? It doesn't start with an F? No.
Don't you have to multiply by 3 to come?
I am so excited to grade your quizzes tomorrow. What do we have to do to get rid of the radical in the denominator? Multiply by 2 plus radical 5. What is that called? What is it called? Oh, say it again. The conjugate. Everybody say it. Conjugate. Okay. Yes, we're rationalizing it, but in order to rationalize, we have to multiply by the. Okay, so we have to multiply by the conjugate. Do we ever change anything other than the sign in the middle?
No.
Never. Okay, so what would I do from here? Yeah, those center terms cancel, don't they? Your middle terms. So you have 4 minus 5. Agreed? What would I have to do in the numerator?
Multiply out.
distribute it. 6 plus 3 radical 5. So I would get 6 plus 3 radical 5 over negative 1. Okay? Now, the dividing imaginary or complex numbers is not that different. We're essentially doing the same thing. Somebody tell me what it was. I don't remember. Okay, so do I have an imaginary value in my denominator? Do I want it there? How do I get rid of it? Multiply by the conjugate. Good. And tell me what the conjugate is, please. Good. Okay, so we're multiplying by the conjugate. Now, in the denominator, do I have to FOIL it all the way out? No. Why not? I want to know why I don't have to FOIL it out completely. What happens when you multiply something by its conjugate? The two middle terms cancel out. Thank you very much. Okay? Your two middle terms cancel out. So you only need to do the first and the last, which is going to give me what? Negative 16i squared. Okay? Yeah, we don't. But what do I know about I squared? Yeah, that I squared is a negative 1, guys, right? Okay, that's good. So we get 4 minus 16 times a negative 1, which is 4 plus 16, which is 20. Okay, so we took care of our denominator, right? Let's talk about the numerator. What do I have to do? Got to FOIL it out completely. So I want you to go ahead and FOIL and simplify out. Get rid of that I squared when you get it. Okay, go ahead. Okay, so in the numerator you get does everybody agree?
Yes.
What's I squared equal?
Negative 1.
Negative 1. So this really would be negative 12. Agreed? All right, so okay, so I have negative 16 plus 2i over 20. What can I do? Yeah, everything's divisible by 2, so we can reduce that. Okay? But am I done? How do I like my answers written?
A plus BI.
Is that an a plus bi form?
Nope.
No, I need to separate it into my real part and my imaginary part. Right now, I don't have that. Okay, so I need to separate it. So, no, you're making it way too hard. Okay, you ready?
Yeah.
That 10 is being divided into both of the pieces in the numerator. Agreed? All right, so we have 8/10 plus, what's the coefficient in front of the I if nothing's there? 1/10 I. Yes, so your calculator tells you negative 4/5 because 8/10 reduces to 4/5 plus. Now is it in a plus bi form?
Yes.
Your calculator gives you this when you pop this in your calculator. Okay? So, is there ever a reason to get one of these wrong?
No.
No, because the calculator will tell you what the answer is. You just got to work back from there if you can't figure it out. Okay? So feel free to work backwards, but you should never get one of these wrong. Are we okay? Don't smirk at me like that. Okay. Okay, so distance of a complex number from the origin, or the length of a vector. What's a vector? It is a good question. What's a vector?
Sounds like sector.
No?
It's a number.
How many of you took geometry?
Unfortunately.
So I will ask again, what's a vector? I doubt that. He's very thorough in his curriculum. It does? No. No.
Slope
People knew the answer in last period. I don't think they go home and study math just for fun. What? Nope. Listen, you're all in trig, which means all of you contain some nerdy. All of you. And you should be proud of it because it is a beautiful thing. I am 100% nerd, and I embrace it. Okay, so I do. A vector, you guys know what a ray is?
Yes.
Okay, a vector is a ray that comes from the origin. Okay, a vector has a length and it has a direction. The word we use for length of a vector is magnitude. Have you guys heard that word before? Yes. Okay, so the magnitude describes the length of the vector. So a vector includes two things, direction and magnitude. Got it? So if I ask you what the distance is, what I'm essentially asking for is I want the magnitude. Okay, the distance, the length of it, I want the magnitude. In order to get the magnitude of a complex number, it's very, very simple. We take the absolute value. What gives us the absolute value for us? Our calculators, okay? So if I wanted the magnitude, there's that word again, I want the magnitude of 3 minus 2i. How do I get it?
Calculator.
Yes, okay. So we're going to put in a calculator page. Sure, I don't know what it was. Absolute value is in the key next to the 9. Math template key. What was it? 3 minus 2i. 3 minus 2i. 3.60 or 3.61 is my magnitude. Okie dokie. So if I ask for the magnitude of a complex number, you're going to do what? Put the absolute value of the complex number into the calculator. Are we good? All right, I'm going to save the last page for tomorrow. We don't really need to talk about it today. Now, your homework says pages 16 through 20. Obviously, it's not every single question 16 through 20 because this lesson is broken up into how many days? 2. So 16 through 20 is actually 2 days worth of homework. So when you go through 16 through 20, you're going to pick out the ones that you know how to do. The rest is going to be tomorrow night's homework. Does that make sense? What's due Friday? Weekly Project 5. What's due next Friday? Your essay. Okay? Your process essay. I will get you a rubric very soon.